Hi, everybody. Here we are back for part 2. We're starting at Roman numeral number 2 on 25.1. 25.1 notes, Roman number 2, heat and absorption and release. So let's talk a little bit about specific heat. It's the amount of energy. Remember, energy is the ability to do work. So specific heat is the amount of energy required to raise, so increase, the temperature of a substance by 1 degree Celsius or centigrade. So if you take a look at 1 kilogram of gold versus 1 kilogram of water, you can put the same flame under each of them, and it takes, the water will just keep heating up and heating up and heating up. So in the same amount of time, the gold is going to get a lot hotter a lot faster. So once it gets hotter, it can't hold any more heat. So it actually has a lower heat capacity than the water, which has a higher heat capacity. And you don't have to know this, but big C sub P, that's heat capacity. So water can hold more heat than just about anything on planet Earth. So water requires a larger amount of energy to increase its temperature than most substances. So water requires a larger amount of energy to increase the temperature than most substances. And when water evaporates, what is it doing? It's actually absorbing a lot of energy, and that's why we're pretty advanced as humans, because we have sweat glands, and in the summertime we can steal the heat from our body, and it can go into the water and evaporate off of us and keep us cool. So you always want to have lots of water around for your body and to drink, so your body can do its job and cool itself off. If not, then you get heat exhaustion and then maybe even heat stroke, and then you're going to have to go to the hospital and they'll have to put you in an ice bath. And you'll be unconscious and you'll feel groggy for a few days and you could die. So make sure that you're paying attention to how much water you're consuming. Turns out that ocean currents, they have a large influence on air masses over the land they contact. We watched the video earlier, and we saw that the reason that England has a pretty chill climate, or a pretty moderate climate, is because this warm Gulf Stream goes cruising by, and the warm water gives heat to the air and keeps England from freezing. And there's this conveyor belt here, and if this conveyor belt's shut off, we're a little concerned that it might send Eastern Europe into an ice age. We don't want to melt too much water coming off of Greenland and shut down that conveyor system. Let's talk a little bit about El Nino. El Nino. El Nino means the child, and its name it's given to the periodic warming. The periodic warming of the ocean that occurs in the central and eastern Pacific. It occurs in the central and eastern Pacific. It's periodic, but it's irregular. Okay, it's irregular. 3 to 7 years, the warm countercurrents become usually strong and replace the normally cold offshore waters with warm equatorial waters. So we want that warm water to be over by Indonesia, but if it gets pushed over near South America and North America, then we know warm air holds more water, and it can actually bring more severe weather here to the western United States, and maybe even cause some droughts. Like in the Rockies, which we'll talk about in a second. But a major El Nino episode can cause extreme weather. That means extra rainfall. extra rainfall or extra snow. We usually have some pretty good snow years in the Sierra around here when we have an El Nino. And we have increased precipitation and landslide activity because then the land can't soak it up. So increased precipitation. And it can actually even bring drought to the northern Rockies because it shifts the pattern of precipitation movement around the planet. The Rocky Mountains. So let me show you a quick video here about El Nino. I think you'll like it. Sorry, I got to go and find it. I thought I bookmarked it. Don't worry, it's worth it. It is worth it. Come on. Well, let's find it here. Little Chris Farley for you. Really? All right, here we go. All right, there you got it. All the way from Chris Farley. El Nino is Spanish for the Nino. Don't forget that. I don't know who that is right there. Mugger versus Ultimate Fighter. Okay. So El Nino is Spanish for the Nino. Don't forget that. All right. So if you take a look at the picture, normal conditions, we usually have these trade winds that are blowing the warm water over here towards Australia and Borneo and Papua New Guinea, Indonesia. That warm water makes everything warm over here. That's normal conditions. So strong trade winds blow from east on the equator. Remember, it comes from the east. We call it an easterly, pushing warm water in to the Pacific Ocean. So away from South America. That's good. But what happens during an El Nino is the current here weakens, and the trade winds in the western Pacific Ocean near Indonesia, and that piled up warm water gets to flow towards South America. Conversely, you can also have a La Nina. And so when surface temperatures in the eastern Pacific are colder than average, a La Nina event is triggered that has a distinctive set of weather patterns, which we will cover in just a second. I'm at 10 minutes, so we're at the end of part 2. We'll move on to part 3.